be a critical mistake. If you call this f comma c, that will be a critical mistake. That is not a typo. Yeah, that is a typo. You can call that a typo. Yes, if you want to call that a typo, it doesn't matter what you call. But if you make a mistake on the one letter there, that is going to be 50 points off right there. This expression right here can only be called f comma x. And how about this guy right here? So here, I'm going to erase this. I'm going to erase this here. So when you see this expression right here, again, when you see this expression, what is this? When you see this expression, limit of f of x minus f of a over x minus a as x approaching a, then what is this? That right there, f of x minus f of a over x minus a, what is that? That's the slope of the line connecting 2 points. What 2 points is that? What 2 points? And that will slope of the line connecting the 2 points, a comma f of a, and what? And x comma f of x. And then that's the slope of the line connecting those 2 points, and then we now take limit. Limit x is approaching a. So what is the variable and what is the fixed value? A is the fixed value, and x is the variable. So this limit right here, you see, that means what is that? By the limit we see x approaching a, that means this guy right here is approaching this guy. So the focus is right here. So this limit expression right here must be called f prime at what? F prime at x or f prime at c? What do you think we should call this guy now? This limit right here, this limit is f prime at where? Can you see this? This is where some of you will make a mistake. Not paying attention to what there is. F prime of what? Should be a. There, it cannot be any other letter. If you put an x here, well, that will be how many points off? 50 points off right there. It's a very critical mistake. You have to be very, very careful with this language here. This language of math is very delicate. It is like making a mistake, one digit mistake on the address, or making a mistake on somebody's name, or in a program. It's a typo. It does not work. In English, you make one letter mistake, that becomes a different word. Okay? But somehow when it comes to math, students try to be too lenient, and students think that it is too harsh to make tons of points off when there's only one letter mistake. Yet we know that in address or in other fields, if you make one mistake, it doesn't work. Okay? Anyway, I'll talk more about that. But here, math is a very delicate subject. One letter mistake will blow up the entire problem. Okay? And then do not tell me that that's a typo. If it's a typo or not, doesn't matter. It doesn't work. It does not work. Okay, so now I'm going to save this and clear all this. What I'm going to do is I'm now going to move on to section 2.3. 2.3 here. 2.3, right. Okay, so section 2.3, I barely explained to you these rules here. Now these are called the rules of differentiation. So section 2.3, differentiation formulas. Now from here on, if you have to take the derivative, then you can just use the formula. Unless I tell you to find the derivative by limit definition of derivative. So if I tell you this, and now let me tell you the instruction here is this basically. Example. Okay, so let me write this here. Example. Find the derivative of f. Okay. In this case, what can you do? You can apply any differentiation, any derivative formula, differentiation formulas, differentiation or derivative formulas. Okay? If I just ask you to find the derivative, or evaluate the derivative or something, find the derivative, then that means you can apply the formula. However, if I say this, example, find the derivative of blah, 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 by the limit definition, I will call it the limit definition of the definition of derivative. If I ask you this, then in this case, what do we have to do? If I give the question this way, find the derivative of so and so by the limit definition of derivative, and you see this term right here. The term you'll see is by the limit definition, by the definition of derivative right here. When I ask you to find a derivative by definition of derivative, that means now we have to apply the definition. So what is that definition? F prime at x is equal to, and then you have to now do this. The definition of this, what is it equal to? This is equal to limit, and then what? Limit, h is approaching 0, or you can use the other version, t is approaching x, or h is approaching 0, and this is now going to be f of x plus h, and then minus f of x, and then divide by x plus h minus x, which will be just h. So you can use this right here, or you can use any similar definition of derivative. So this is what? F of x. In this case, we have fixed points, f of x, x comma f of x, and then x plus h comma f of x plus h, and then h equals 0. That means the 2 points are approaching x comma f x. So this is f prime of x. So you have to use this definition right here. This is the definition of derivative. So if you see the instruction, find the derivative of so-and-so by the definition of derivative right here, usually I will call this the limit definition of derivative, because this definition of derivative involves the limit. But if you see the definition of derivative, that means you have to apply this guy now. Not by formulas. In this case, this means not by formulas. No formulas here, no differentiation formulas, or no derivative formulas. Any questions on this instruction? I think so many of you are not following the instruction here, and so I'm telling you how you follow the instruction. If I ask you to find the derivative, then what? Then you can use any formulas on derivatives. But if I ask you to find the derivative by the limit definition of derivative, by definition of derivative, this is the key right here. Definition of derivative here. When you see the term definition of derivative, what does that mean? Then that means you have to use this definition. In this case, you cannot use the differentiation formula. But is that clear? I think that I make this clear, but there's always somebody who who kind of ignores this, so that's the problem. Okay, so now let's look at example 2. We kind of started this yesterday, but let's do it anyway. Okay, so example 2, I did it. Okay, yeah, but let's do it again one more time. I rushed too much yesterday. All right, so what is that? So what is it? What is it here? So we have f of x equals this right here, and so now we want what? Find f prime of x. So what is f prime of x? Well, this is f of x here, and it says here, find f of x. Now, according to the instructions, do we have to apply the definition of derivative or not? What do you think? On number 2, is the question asking for the derivative by the definition of derivative? This right here, yes or no? Does the instruction say that we have to use this definition? Yes or no?
No.
No. Now, let me make it very clear. So if I want you to find the derivative by definition, then you will see this. Find the derivative by the definition of derivative right here. Definition of derivative. You will see this term. Definition of derivative, okay, that means you cannot use the formula. And if you use formula there, then the whole form will blow up. You're not following the instruction here. So you have to find by the definition of derivative. And by the way, this definition of derivative it is not just in chapter 2, but this definition of derivative will appear throughout until calculus, until calc 1, calc 2, calc 3, and then you go beyond calculus 3, and then you take any other math, this definite derivative will show up again and again and again. Is that clear? So that definite derivative will be applied again and again. In our class, yes, it shows up in chapter 3. It shows up in chapter 4. Shows up in chapter 5 again. It shows up again and again. And you go to calculus 2, it shows up in chapter 6. Shows up in chapter 7. Shows up many, many times throughout the entire calculus, including calc 1, calc 2, and calc 3. And even advanced calculus or any other calculus, any course after that, this guy will show up again and again. This definition you have to know, all right? Okay, so in this case, does not take definite derivative, so in this case, we can apply the formula. So f of x is this right here. So what is the best way to apply any formula here? Well, look at this here, that form, we have all these formulas here. The derivative of a constant is 0, and then the derivative, again, this d dx, when you say d dx, the notation is that d dx of, you know what, let me use a thinner font. So in this case, let me say this. So d dx, the notation is, when you have this d dx, this is what we call the operand notation. Operand notation, we write d dx of f of x. So when you write d dx of f of x, this right here, this is the d dx of f of x, that is the same as f prime of x. Although a little bit later, when you get to section, I think section 2.6, this has to be adjusted a little bit, but we have this notation right here. Okay? And of course, if you use the, this is actually called the Leibniz notation. There's another notation called the differential notation, D. This is actually called the Operand notation. F of x, actually mentioned in what? Section 2, I think it was mentioned in section 2.2. We also write it this way as well. But in this class, we'll probably use this notation and that notation. The other notations are common in other math classes, in other advanced math classes. But in this class, you know what? These are the notations we'll be using, so it will not be that critical. Okay, so I didn't spend too much time there. Okay, so now, what is this here? It says here, the derivative of a constant is 0. Yeah, that makes sense. If you have a constant function, the derivative is always 0. Tangent line is 0, yeah. And then the second number 2 is the power rule. Now, this power rule, you should be able to prove for individual n's. In the simple individual n's, such as when n equals half, or n equals 3, or 2, or minus 2, but we cannot prove this as a class, as a whole. You cannot prove this once. The general proof of this guy, for this formula right here, will be covered in calculus 2. All right? So when you go to calculus 2, you will see the general proof of this. Again, in this class, you should be able to prove this. So when n equals half, or 2, or 1/3, or 2/3, and maybe I can do one of them, but we have already done a few of them already. Okay, so anyway, make sure that you know the proof of this. Now this one, C, number 3. If you have the derivative of a constant multiple, sometimes we also write like this: C times, and then G of x. So if you have f to G of x, here we name the G of x. If you have a constant times a function, and then we take the derivative. This is a dot times. C times G of x is times here, and to take the derivative, this is the same as C times G of x. G prime of x. So that's what that is. Okay? This right here. Now if you look at the left-hand side is the derivative of C times G of x. We are taking the derivative of the function called C times G of x. If you look at the right-hand side, we are only taking the derivative of G of x, and this is C. This is C times the derivative of G of x. The left-hand side is the derivative of the function called c times g of x. So the meanings are different, but they're equal. Is that clear? Make sure you understand the meaning of these formulas here. And then example. Now let's look at this example 2. Okay, and then here is number 4 is the difference, and the sum. The derivative of the difference, the derivative of the sum is the sum of the difference. The derivative of the difference of two functions is equal to the difference of the derivative. We call it the difference of the derivative of functions. Okay, so that's what that is. So in a more precise notation, we can write like this. G plus h. If we assume that g of h are functions, then what is the derivative of a function called g plus h? So here we take the derivative of the function g plus h. And then it turns out that if you have that, then that is the same as taking the derivative of g and taking the derivative of h and then adding them together. That's what it means. So make sure that you understand them correctly. So the two sides mean different things. They mean different. But the result is the same. That's what they're saying. It means different, but they're the same. Means different, but they're the same. Yeah. Okay? Okay, so what is this? So this is now the difference of two formulas. So we have the difference formula here. So we have to take the derivative and the that. We can take these terms separately. So first, why don't we rewrite this here? We can apply power rule. So this is actually called x to what power? 1 over x squared of x is x to what power? Minus 3 over 2. The minus x squared of x, that's x to what power? 3 over 2. So that's f prime. That's f of x. I didn't take the derivative yet. Why did I write this expression in this form? Because the power rule is about to be applied. And when you look at the power rule, the function is written in the form x to the n power. And so we want to write this 1 over x squared of x in the form x to the n power. In this case, x to negative 3 over 2. That's much better. Of course, after this example 2 comes the other two rules here, product rule and the quotient rule. But these rules are the ugliest rules out of all the differentiation formulas. Again, the quotient rule is about the ugliest rule, is the ugliest rule among all the differentiation rules. So we try everything not to apply the quotient rule. So when you study the problem of the quotient rule, the first thing you have to learn is how can you avoid the product rule and the quotient rule, especially the quotient rule, because they are the ugliest rules out there. So that's what you learn. You learn a rule. The first thing is you have to learn how to avoid the rule. Is that clear? It's like taxes. You learn taxes, and then you learn taxes. Now we have to learn all of us. We have to learn taxes, not to learn how to pay more taxes, but we learn taxes so that we can pay less taxes. Right? Of course, it can't be legal, but we try to minimize our taxes. In some ways, very similar. We learn these rules, and so one of the things you have to learn about that rule is when can you avoid that rule. That's what we learn. Okay, it's like one of the rules for studying calculus. Is there a way to avoid calculus? So that's a good thing. If you can solve a problem, I think I told you this before. If I give you a calculus problem, and then for somehow you can solve a problem without calculus, you know what? I like that. In that case, I might give you even bonus points. I'm very good at that. If anybody can solve a problem, solve a calculus problem without calculus, then that's great. Of course, the non-calculus method has to make a sound argument. It has to be correct. But if it's correct, what? Then I give you even more points. So that's what you have to learn. Then how to avoid calculus. Okay, so we have this. Now part A. Now it's time to find f prime. So what is f prime? F prime is that? Now this is different here. So we have to what? take the derivative separately, because that we have now the rule number 4. If you have a difference of two functions, and we take the derivative, how do you do it? We just take the derivative separately, and then it takes the difference. So the derivative of the first term is minus 3 over 2, and then times x to negative, negative 3 halves power, or negative 5 over 2 power, and then minus what? The derivative of x to 3 over half, which is 3 over 2, and then times what? X to the half power. 3 over 2 minus 1 is half. And then this right here. What rule did I use here? Well, the rule I used was I used rule number 4. Then I used rule number 3. This I used the sum. Again, you know, these rules, they really don't have any name, except number 2 has a name. Number 2 is called the power rule of differentiation. Okay, number 2, this is called the power rule of differentiation. So let me write this down. Power rule of differentiation. Or power rule of derivatives. Differentiation is same as the derivative. Differentiation formula, these are called the differentiation formula, also called the derivative formula. Okay. The process of taking the derivative is what we call differentiate. The differentiate means take the derivative. Okay, taking the derivative or finding the derivative. So now, now we can actually what? Oh yeah, we can simplify this guy. Now, do you remember how to simplify this guy? Oh yeah, we have a fraction here as well. Minus 3 over 2. So this is actually equal to minus, why did I get this? You know why it turned to gray? Sometimes I want to do this, but I cannot. But in this case, it's just, I'm not sure. How did I change this to gray here? I think it's black. Oh, now it's black again. Again, I'm not sure how this turns out to be. So anyway, this one, let me just undo this guy. Okay, this is now equal to, let's look at this. This is minus 3 over 2. Then that's the numerical factor. And then now what? Times x to what power? X to the minus 5 over 2. So this is 5 over 2. And then what is going to be here now? This will be x cubed. X cubed? Will it be x cubed? No, sorry, that is not x cubed. That is not x cubed. Let me factor that. That will be 1 minus x cubed. So this is now what? The derivative. Now, if you leave it like this, you know what, for now, that's okay. You leave it like this, that's okay. However, when we go to the next chapter, in chapter 3, where we will be dealing with curves, we need the factor form. The factor form. So this is now the factor form. That factor form, you know what? Actually, the factor form is like this. Let me just move on one more step here. This is actually what? This is actually 3 over 2. And then times x to the negative 3, negative 5 over 2 power. And note that this here, the other factor is what? X1 minus x cubed, but there's a minus in front of it. So this can actually be written as x cubed and then minus 1. Now, do all of you know how to factor x cubed minus 1? I think by this time, aren't you tired of this guy? But in this class, you better know this guy before it's too late. So this, now we can factor this. So factor this one here, this is going to be 3 over 2, and then times x to the negative 5 over 2 power. Or you can write 1 over, you can write x to the 5 over 2 in the denominator. And then now we have x minus 3, x cubed minus 1. And that will be x minus 1. And then times x squared plus x, and then plus 1. And by the way, this quadratic factor, this one cannot be factored any further. This right here is called the factor form. The factor form of f prime. This is now the factor form of f prime. that clear? And this is what we need in chapter 3. Need this form in chapter 3. So when I say, now class, this is not my general recommendation. Now right now we are in chapter 2. So when I tell you that this is something we need in chapter 3, this is my recommendation. Do this, convert this into a form with the form we need in chapter 3. Just start doing it this way. And this will prepare you to do problems in chapter 3. So practice this way, do it this way, just make an adjustment right now. However, of course, you have a leeway. In chapter 2, this will be acceptable in chapter 2. This one, chapter 2, is it acceptable? Well, it is acceptable. But I think, and you know what, I don't want to guarantee anything here, but ultimately, this is what we need to do. So right now, let me just write the comment. And so that is the end of that process. Again, for this problem, if you just give me that expanded form right there, the non-factor form, in general, I will accept that. But now let's look at what? Part B. What is part B? Part B now. What is the tangent line to the curve at 1, 0? What is the tangent to the curve y equals f of x at 1, 0? So in this case, first, we have to get the slope of the tangent line. So what is the slope of the tangent line? The slope of the tangent line to the graph y equals fx at 1, 0, that will be, again, what is the slope here? The slope is equal to what? It's going to be f prime at 1. Is f prime at 1? F prime at 1. By the way, is that point 1, 0 on the curve? Is that point on the curve? Is that point 1, 0 on the curve? Is 1, 0 curve? Is it?
Yes.
Yes, it is. When you plug in 1 here, just plug in x equals 1 here into the function. The 1, 1, 1 becomes 1 minus 1 equals 0. So 1 minus 1 is 0. But I always want you to verify. Always verify these points. Always verify these points. Always. Now, with all the points given on the problem, will the points always be on the curve? So on all the problems in here, on this chapter and later chapters, the points I give you, will they always be on the curve? And the answer is what? No. No. The points I give you, or the points given on the question, may or may not be on the curve. And as we get into later sections and later chapters, that will be so. So that's the reason why you have to verify. Can you assume that the point you see on the problem is always in the curve? No, you can't. Some of the points will not be on the curve. So that's why I want to verify. Even if the problem says that the point is on the curve, I want you to check it yourself. Make sure that the point is on the curve. You check it again. Is that clear? Check it. You don't want to make a critical mistake here. You have to verify that this point is actually on the curve or not on the curve. Make sure that you figure that one out first. Because if it's not on the curve, the problem will completely change. And we will get to those kind of problems. Yes, we will. Don't worry about it. We will get to those. So now, f prime of f, what is f prime of 1? F prime of 1, what is it? So f prime of 1, what is f prime of 1? F prime of 1, we plug it in. F prime is right here. So we can actually plug this form or to this form, doesn't matter. Oh yeah. If it's in factor form, it's very clear. Plug in 1, we get a 0. So this is indeed 0. If we just plug into the raw form right here, the expanded form right here, the form which is not factored, you plug in 1 here, and you get minus 3 over 2. You know what? Actually, we do not get, we get 1. We 1 here, 1. Wait a minute. Did I make a mistake? You know what? I did make a mistake. I did class, you know what? I noticed that I did make a mistake. Where's my mistake? Can somebody tell me?
Was it a mistake with the derivatives?
Yeah, where's my mistake?
I think it's because it's not supposed to be 3 over 2.
No, minus 3 over 2 is correct. It should be minus 3 over 2. This right here, this right here is actually correct. But then now let me write this in red here. This is actually 5 over 2. Yeah, sorry about this. This should be 5 over 2. This should be 5 over 2. What is this? 5 over 2, sorry. Not 5 over 2. What should that be? So let me erase this part right here. This is, yeah, well, you know what that is that minus 5 over 2? Oh, yeah, that's minus 5 over 2. You know, I made a lot of mistakes here. Why did I make this mistake? This should be 2. So let me write 2 here. And then this should be minus 5 over 2 right here. This should be minus 5 over 2, okay? The mistake I made was not that. That's kind of hard to see, but it was minus 5 over 2. The mistake I made is actually right here. This should be what? This should be, let me write this in red. This should be a plus. If you are backing the minus sign. And if you do that, then this becomes a plus. If you put a plus there, then this will be a plus. And then this will be a minus. So that was my mistake. So now I made the correction. Okay, I made a mistake, but I made the correction. So now what happens if we plug in x equals 1? Then now this will be wrong, not 0. So when you plug in 1 into the function, 1 into x prime, then what you get? Now we're going to evaluate what x prime of 1 is, then that will be minus 3 over 2 minus 3 over 2. So that will be what? Minus 3. Oops. Oh yeah, minus. This will be minus 3. So let me just write this minus 3. So what we have is minus 3. So what we have is this. So what is the answer to part B? Part B says find the tangent line to y equals fx at 1, 0. So we need to find the tangent line to this curve at 1, 0. It will be, the slope will be negative 3. And the point is 1, 0. So what is the equation now? The equation is going to be y. So let me put the line there. So it's going to be y minus 0 equal to, what is that equal to now? So this is going to be, therefore, what is the line going to be? So let me just write down the equation. Therefore, it's going to be what? Y is equal to y minus 0 is 3, and the minus 3 times what? Times x and the what? X minus 1. There we go. So you can write this as y is equal to what? The minus 3x plus 3 if you like. Okay, so that's the same as writing y is equal to y to the minus 3x and then plus 3. Is this? Is the y equals minus 3x plus 3? Yes, it is. That's it. Okay? You can verify this using a graph if you want to. That is. Now let's look at part B. What is now part B? What's the normal line? Part C, what is the normal line? What is the normal line to this to this curve at that point 1, 0? What will that be? So the part C, the normal line. So this one's actually quite easy. All we have to do is write y is equal to what? 1/3 times x minus 1. Instead of negative 3, all we need is what? 1/3. Yesterday I showed you the normal line, right? When you get to the graph, this is now the equation of the normal line. This is the normal line to the curve y equals fx at 1, 0. At 1, 0, we find the slope of the tangent line, negative 3. The normal line should have the negative reciprocal, therefore should be 1/3. The normal line is the line which is perpendicular to the tangent line at that point. So this line passes from 1, 0, and the slope is the negative reciprocal. That's it.
To find the tangent line, did you just plug in 1 to the derivative that we found on part A?
this is part A example. Part A is right here. F prime at A, F prime at X is this guy, and this is now the derivative. Now the derivative.
Then if you plug in 1.
Plug in 1 into the function F prime. So F prime of 1, replace X by 1. If you plug 1 here, then you plug in 1 here, 1 here. 1 to the anything power is 1. Therefore, negative. So we get negative 3 halves minus 3 halves. So minus 3 over 2 minus 3 over 2, that's minus 3. So I thought that was simple enough, and so I didn't show you any words here, but you know that's I think easy enough for us to figure out. So yes, we do plug in 1 into the function F prime at X, because we have to find F prime at 1. So plug in 1 here, 1 here, 1 here, you get minus 3. Capiche? Entiende?
Yes.
Yeah? Okay. And then the normal line, you just get the normal line. The line which is perpendicular to the tangent line. So if the question is a normal line, you must always get a slope of the tangent line first. And then, or sometimes the tangent line it could be a horizontal line. But if the tangent line has slope 0, which means it is a horizontal line, there is still a normal line. Normal line always exists. Is that clear? So whenever there's a tangent line, the tangent line is y to the 1/3 times x minus 1. That's it. Okay, so let me now save this and clear all this. Now let's move on here. I'm going to bring this down. And now we have example 2. Yeah, we have what do we have here? We have the product rule. The product rule is this right here. Product rule is this. Annotate f times g prime of x is equal to f prime times g plus f times g. So let's say let me give you a small example here. I'm not going to prove this. The proof can be found. So here, the proof of this can be found. I will not. Okay, so here what I'll do is this. Study all these proofs. Proof was found on Paul's notes. It is also, I have some of these files. The one it says here, if you look at 0. This is actually the file. It's actually a file. 0723, and then I call it B, then I call it diff, then a pulse notes. Yeah, so you know what, that's what I named it, okay? If you open up that file, which is right after this file, then you will see the pulse notes there. And on that file, you will find all the proofs, okay? Or you can, of course, all these proofs are found on any calculus textbook. Every calculus textbook, almost all the calculus textbooks, they have proofs, okay? I have yet to find this calculus textbook which does not prove these formulas, okay? So it's everywhere. Or on the internet as well. So these are the rules here. So now, let me now give a simple example. So what I'm going to do is, let me just give a simple example. I have not given you any example on product rule here. I think it's kind of my mistake. I should have given you this. So let's say f of x is equal to, let's say, how about this? X cubed, let's say x cubed, and then let's say plus, how about let's say 1, and then times x2, let's have a 2x squared, how about 2x, and then minus x, and then let's say plus, let's say 5. Let's say we have this. Now we can now put some parentheses here. X cubed. But you know what? Should I make this example a little bit simpler? Maybe I should. You know what? How about this? Let me undo this here. Okay. You know what? How about if I just do this? X plus 1. You know what? How about if I just put a square here? Let's just do that. Let's say f of x equals x plus 1 times 2x squared minus x, and then plus 5. So how do you take the derivative? What is f prime of x? Okay, so in this case, so let me write this down. F of x is equal to f prime of x is equal to now, I'm going to copy this for now, x plus 1, and then I'm going to put a derivative here, and then times 2x squared, and then plus minus x, and then what, plus 5. Let me put this, and then plus, and then what I'm going to do is I'm going to write x plus 1, x plus 1, and then times, we have 2x squared, and then minus x, and then plus 5, and then I'm going to put a prime right here. So what I'm going to do is I'm going to put squared here. Now this step, you don't have to write. So what it was, if you consider this as f and this as g, if we consider this as f and this as g, consider x plus 1 as like an f. Of course, we have f here, so just call that maybe g, and call the other function f, g and h. This is like f of x is h of x times h of x, g of x times h of x. Then this is g prime h plus g h prime. So that's what the product rule is right now. This is how you find the product rule. Then what is that? So what is the derivative of x plus 1? Oh, and what is the derivative of x plus 1?
1.
Oh, that's the sum. So we can take the derivative separately. The derivative of x is 1 and the derivative of 1 is 0. So therefore the whole thing becomes 1. So this guy right here, this whole thing becomes 1. So that's it. And then it times this. So therefore that whole thing disappears. So we end up getting 2x squared, and then what? Minus x. And 2x squared and then minus x and then minus 5. Plus 5. This works good. And now what is and then now we have a sum. So because it is a sum, we can write this. What is that now? Plus. This is going to be plus. And then now what? Oh, this one is x plus 1. And then now times the derivative of 2x squared minus x plus 5. What is that? That will be 4x and then minus 1. So the derivative of 2x squared minus x plus 5 is 4x minus 1. Why is the derivative of 2x squared minus x plus 5 equal to 4x minus 1? So let me explain that to you. If you do not know that yet, let's look at it here. 2x squared, and then what? Minus x, then plus 5. We now want to take the derivative of this. So the derivative, let me now apply the more concise notation. The derivative, we take the derivative here. If you now take the derivative of this guy, then what is this here? This is equal to taking the derivative separately, 2x squared, and then now we have difference in sum. So take the derivative here, and then minus, take the derivative of x, and then here, and then plus 5, take the derivative of 5. So again, the derivative of the sum and the difference is the derivative of the sum and the difference of functions is the sum and the difference of functions of its derivative. So you can take the derivative separately and then add them up or subtract. But this is only for addition and subtraction. And now what? Let's put a bar here now. When you do that here, now what is the derivative of 2x squared? The derivative of 2x squared is equal to 2 times the derivative of x squared. So I'm now applying the constant multiple formula. The constant multiple formula is that formula which says c times f of x, c times f of x. And what is now the derivative? C times f of x. The c times f of x, the derivative is the same as c times f prime f of x. So that will be what? That is equal to c times f prime of x. So that is the constant multiple formula of derivatives. Actually, these formulas they don't have official names, so that's what I call it. And so now we have this, and we take the derivative. And then this one is 1, and then this one is plus 0. Now, what is the derivative of x squared? That will be 2x. Now, this is the power rule. 2 times and then 2x, and then minus 1. 2 times 2x is the times here. And so the result is 4x minus 1. Okay? So all these processes are very similar, and so simple enough. So when you see this right here, we take the derivative, it's going to be 4x minus 1. Right there. And then that's how we get the derivative. Now note that if you take the derivative separately, that will be incorrect. So let me put a note here. Note. Note. F prime of G prime is not, okay, so let me write this. Note. So what is it? F times G and then prime is not equal to F prime is not equal to F prime and then times G prime. So let me write this down. Times into what? G prime. This is sometimes well, sometimes some students make this mistake. Okay? F times G prime is not F prime times G prime. It kind of looks like it. Kind of looks nice, right? But it's not. You can try it, and it doesn't work. Now, of course, the other way of finding the derivative of this guy is you can expand this guy, and then take the derivative. Yeah, that will be easy too, right? But of course, this product is easier in this case, and so you can check that this is indeed the same guy compared to the compared to the one you get by taking the derivative after you multiply them. You can verify this. Verify if you apply this here, that will be a different function. So they're not the same. Okay, so, and if you just leave it like this, okay, that's okay for now. Or generally, of course, you don't expand all this and then simplify this. So the question is, okay, how about this? I'll just write then simplify. Okay, then simplify. Okay, then just simplify this. Okay, that will be easy matter, so I'm not going to do that right now. Any questions here? Any questions of the product rule? So F times G of the prime is equal to F prime G plus FG prime. That's called the product rule. Now, the second rule, the one below that, is called the quotient rule. Again, this number one is called the product rule. It is called the product rule. The product rule of differentiation. It's called the product rule of differentiation. Oops. It's going to put it over here. Let me write this in red. So this guy right here is called the product rule of differentiation. This right here. And this number 2 right here is called the quotient rule of differentiation. The quotient rule. Okay, so the quotient rule of differentiation. Okay, if we just say product rule of quotient rule, there are so many rules. There's product rule of exponents, product rule of logs, product rule of integration, product rule of this and that. So there's so many product rules out there. So to be in this chapter, we can just call it the product rule. But once we go outside this chapter, then you have to specify, what rule. Name is the product rule of differentiation. Of course, I will never ask you for the name, but this is what it is. Okay. So if somebody, let's say we go to, let's say, a later course, you go to Calc 2, and then they talk about product rule, then you have to know what product rule. So this rule, they will call this the product rule of differentiation and quotient rule of differentiation. That's the name. Okay. So now let's look at how about this example 3. Example 3. So let's look at this. Okay, let me just erase this part here. So we can see the product rule. So now let's look at example 3. Y is equal to x over 1 plus x squared. Find the tangent line and normal line at 1, 0, 0, and 1, half. So for example 3, let's just do what? Let's just do part B. You can do part A. Why don't we try to do this part B here? Okay. Yeah, part A, same thing. Okay, but it's very similar. Okay. Now let's look at this. Example 3, we have this function right here. So now what we're going to do, now we have to find the tangent line. The tangent line means we have to take the derivative at that point. And the normal line. Okay, so now, how to find the derivative of x over 1 plus x squared? Well, this is not a polynomial. So now we need to have a special rule. Looks like we can apply what? We can apply quotient rule. We can apply the quotient rule. So in this case, apply quotient rule. Apply quotient rule. Now the question is, can we avoid quotient rule? Actually, we have no other way. In this case, we have no other way. We have to apply the quotient rule. If you find any other way, actually, you know what? There's actually a way. Let me erase this. There's a way to apply the product rule instead of quotient rule. Why is that? Because the quotient can always be written as a product. So if you want to, then you can apply the product rule. But anyway, you know what? Anyway, in this case, why don't we just apply the quotient rule? So how do you apply the quotient rule? Okay, the rule is right here. By the way, even though it's open book, I do recommend you to memorize these rules. These are considered as very basic rules. I think you should what? You should memorize them. Or at least semi-memorize them. You almost memorize. Okay? If you forget, you can look it up again. But you know what? Just looking at this rule every time you need this rule, that's not a good sign. Okay? So that is not a good sign. So memorize this rule here. So now in this case, what is y? We can write the derivative as y prime. So what is y prime? Y prime is now, see, I'm going to apply the quotient rule. The quotient rule says that the g squared is the denominator, so g squared. G squared is going to be 1 plus x squared, and then squared. So that is our, again, we are trying to apply the formula. And then it's going to be now what? F prime g minus fg prime. Our f is our x, f of x is x, and g of x is at 1 plus x squared. So what is f prime? F prime is 1. So that leaves 1 plus x squared. F prime g, so f prime g is this. And then minus fg prime. F is this. Then g prime is the derivative of 1 plus x squared, which is 2x. So we actually get this. 1 times 2x, so I want to just put a parenthesis around this. So what we get is now this. This is equal to now, what? 1 plus x squared minus 2x squared. So that will be minus x squared, and then plus 1. You know what? The line is not straight in here. So let me rewrite this. So I'm going to write this as minus x squared, minus x squared, minus x squared, and then what? Plus 1 over x squared, 1 plus x squared. Yeah, I can just write this as x squared, and then plus 1, and then squared. Now, this is in factor form? No, this is not in factor form. In fact, this one is going to be, we can factor out the minus x. And if we factor out the minus there, minus, then we will get, the numerator actually becomes what? This. Minus, and then x minus 1, and then times x plus 1. This would be the factor form of the numerator. And the denominator, there's not much we can do, so we just copy. X squared, and then what? Plus 1, and then what? Squared. So let me just put the squares there. So this would be the factor form. Okay. This is what we actually need when you get to chapter 3, the next chapter. In this chapter, you kind of get by. So if you want to, you can just, look at this form right here. That's okay for now. So now, we are now trying to do part B. So part B, in order to do part B, what is that we have to do here? Okay, so let me write this down. Okay, so what I'm going to do, first let me erase this. Then let me erase this part through here. Let me erase this note. Oops. Wait a minute. When did I write there? Okay, there we go. So now, let's look at part B. What is part B? Okay, so part B. So part B now, so that's the point right there, 1 comma half. And so now, in order to find the tangent line, what we need to do, we need this. We need f prime, we need y prime at x plus 1. By the way, when you have y prime here, the notation you use is, of course, we can call it f prime at 1 if you like, if you want to. But here, since we call it y prime, sometimes we are going to write it this way. So we write 1 prime, and then 1 prime, and then I evaluate x plus 1. We have to write it this way. Of course, that is the same thing as f prime at 1 if you like. That's the same as this guy. If you want to write this guy, it's x over f of x instead of y here, but in this case, you have to say that this is indeed equal to f of x. So if you say that this is equal to f of x, then you can use this notation, f prime around. Otherwise, you can write it this way. So what is y prime or f prime at x equals 1? Plug it in, what do you get? So what is y prime at x equals 1? Can somebody tell me what that is? What is that?
It's 0.
Yeah, you're right. So now the next big, the final, the answer to the question: what is the tangent line at this point? What is the tangent line? Oh, sorry, we're not doing part A. We are doing this time. We're doing part B. Sorry, part B. The point is 1 comma half. The slope is 0. What is the tangent line? What is the tangent line? Can you tell what the tangent line is? Can you tell what the tangent line is? What is the tangent line? Therefore, tangent line is what? What is tangent line? Do you have a tangent line or not? Tangent line is what? What is tangent line?
Y equal to 1 by 2.
Y plus half, you're right. Tangent line is y is equal to half. So basically the slope is 0, but it passes through the point 1 comma half. So there's the tangent line. Now the next question, what is the normal line? What is the normal line? Do you have a normal line or no? Normal line? What is the normal line? The normal line is, what is the normal line?
Wouldn't the normal line just be y?
What is it?
Wouldn't the normal line be y equals -2 times x minus 1?
Okay, wait, 1 second. You said the normal line is what? Y to the what?
Y is equal to -2 because it's the reciprocal of the slope times x minus 1, right?
That is incorrect. You know why? Because this -2, you say this -2 is the reciprocal of half, right? But note that the tangent line, this half is not the slope. What is the slope of the tangent line? The slope of the tangent line is 0. It's not half. In case you didn't know. See? This tangent line has slope 0. Y plus half, this is really y is equal to 0x plus half, if you like. So the slope is actually what? It's actually 0. It's not half. Again, half is not the slope. Therefore, the slope of the normal line is not the reciprocal of half. It should be the slope of 0. So what is the reciprocal of 0? Negative reciprocal of 0? Well, it's undefined. So does that mean that there's no normal line? Because this tangent line has slope 0. But if we have a horizontal line here, what line is perpendicular to the horizontal line? It is a vertical line. So there is a normal line. So what is the equation of this normal line? What is the equation of the normal line? Normal line is what? Does that exist? No, there is a normal line. What is the normal line? The normal line we see is this. Because the tangent line has slope 0, as in the tangent line is slope 0, this guy is a horizontal line. So let me say horizontal line. This guy is a horizontal line. I'm sure that you know that is. It's a line which is parallel to the x-axis. So y equals 0. Anyway, this is y equals half. Therefore, the normal line must be a vertical line. But the normal line has two properties. It must be a vertical line, and it must pass through the point 1 comma half. What would that be? What would that be? That will be what? Can you tell me? What is the normal line? The normal line is? What is the normal line? The normal line is what? The normal line is the line x equals what? 1. You get that? Okay, and clear. I'm going to clear all this. How about this? Let me now move on to the graphing. Okay, I don't want to. Let me move the decimal. This is decimal. This is the decimal here. But you know what? I cannot do this here. It's so messy. So what I'll do is I guess I'll have to go back to our files and erase all this. Okay, so I have no choice here. So let me just save this and I'll give this, and then I'm going to clear all this. So what I'll do is I'm going to go here, go to my decimal file, and there we go. And now let's look at our decimals. Am I sharing this page here? Yes, I'm sharing the decimals. So here, what I'm going to do is I'm going to change. Oh, you know what? Did I type this in? This is the function. Oh yeah, that is the function right there. So that is the function. So what I'm going to do is I'm going to this here. So first of all, let me explain the graph here. This is how the graph looks like. What is the graph of this? This is the graph of the equation. F of x is equal to x plus x squared over 2. X over x squared plus 1. So this is how the graph looks like right here. Okay? So now let's look at the tangent line. What is the tangent line? The tangent line looks like this. This is the tangent line right here. That's the tangent line. Now what I'm going to do is I'm going to add the normal line. This is the normal line. So now what's the point here? The normal line, our point is, the point in question is 1 half. 1 half is over here. Oh, right here. Right here. That's the one right there. See the point 1 half? 1 half. Now remember, this graph is an approximate. It's an approximate tangent line. Why? If you look at the left-hand side, I could not really let the h approach 0. So the h is really 0.001. So what that means is this is an estimate. By using a graphing calculator, we cannot really draw the tangent line. We can. Is that clear? So this line, the blue line you see right there, is actually approximate line. The approximate line, and therefore, but as you can see, it looks like a horizontal line. It is slope 0. Now here on this graph, the slope is not 0 because you see the slope is right there. So we see the slope minus 0.0002. Okay? Well, that's only an estimate. But mathematically, when you actually get the slope of the tangent line, it's actually 0. Anyway, with our naked eye, it looks like that blue line is almost a horizontal line. But mathematically, it is a horizontal line. We found it right there, in the other sheet. The equation is y equals half. If that is the line, then what is the normal line? The normal line will be a vertical line. And this vertical line will pass through the point 1 half. So what is the equation of this green line? Can you tell me?
Would it be y equals to 1?
Y equals what?
Y equals to 1?
Y equals 1?
Yes.
No, that line is not y equals 1. The green line is not y equals 1.
Henny.
Green line is what? Green line is?
Man, I had a scary dream that was based on the movie, and I woke up scared.
You see the green line?
It was like, you thought someone was like hiding in the closet or something. You were there and you were like freaked out.
The y+1 would be over here. This line would be y+1. Because 1 is right here.
And then there was someone like hiding in this thing. It was like a baby or like a kid, and then it was a man, and it was like a, it was just, I
Yes.
don't know, I woke
How
up.
did you find 1
It was scary.
for the normal line?
Because this point must be a vertical line, and it must pass through the point 1 half. Okay, so here, let me go back here. Now I'm going to save this. Now I'm going to, and then I'm going to clear all this. Now let me go back to the file. Back to this here. So now we are back to the example 3 here. So if you look at this, if you look at this part B here, the part B. So let me now go back here. The here is in part B, and this one here is a tangent here, the slope of tangent, the slope of tangent, the slope of tangent, the slope of tangent line came out to be 0. And because the slope of the tangent line came out to be 0, we know that this guy is a horizontal line. This guy is a horizontal line because slope is 0. And we know that we are looking for a line which is a horizontal line, which passes with a point 1, half. So therefore, what is the tangent line? The tangent line is therefore equal to what? The tangent line is therefore equal to what? Therefore equal to y minus the half. This is the tangent line. Now note that this y equals half. It's really y is equal to 0x plus half. 0x plus half. But we don't write it that way. If 0x is 0, and so we don't write that. But if you write this line in slope point or slope intercept form, it's actually this. Note that the slope is 0 here. It is a horizontal line. Now, how do you get the normal line at this point? How do you get the normal line? So here is a thing. What is the normal line? Now you want to get the normal line. The normal line must be normal line must be a vertical line. So how does a vertical line look like? What is the equation of a vertical line? The vertical line equation is always like this. Vertical line is always equal to x equals and then something. It's the line x equals
Do you know
something.
where the cups are?
Then
The
you
mugs?
It's the line x equals something.
They're in the
Not
dishwasher?
the number.
I just needed some water to rub it out again.
Must pass which point? What is the point in question? What is the point in question here? This line will pass.
1 over, sorry, 1 and 1 half.
Yeah, it must pass 1 and half. So it must pass 1 comma, and then it must pass the point 1 comma half. So now the question is 1 comma half. Now what is the equation of the vertical line which passes the point 1 comma half? You tell me.
X equals 1.
X equals 1, exactly, that's what it is. And just before this, you saw the graph. And so you can see what's happening here. So the equation is yx equals 1. Now when you say, when I ask you for the normal line here, the answer is x equals 1. It is not 1. Not 1. Don't tell me that the normal line is 1. There is no such sign. There is no such line as 1. If you write the normal line is 1, that will be a mistake. The normal line can be x equals 1, it can be y equals 1, but it cannot be 1. 1 is not a line, is that clear? If you write 1, I'm not going to see, there is no line called 1. Here, when you say the normal line is x equals 1, we are talking about the equation x equals 1, it's not 1. It's x equals 1, not 1. Is that clear? Not 1. So don't tell me the line is 1. There is no line called 1. Not 1. Okay, so not 1. There is no line. There is no line. There is no line called 1. There is no such line. There's a line called x equals 1. There's a line called y equals 1. There's a line called y equals x equals 1. But there is no line called 1. So here, the line, the vertical line is x equals 1. If the horizontal line becomes if the tangent line has slope 0, is a horizontal line, then don't say that the normal line does not exist. The normal line is still perpendicular to the tangent line, which is in this case perpendicular to the horizontal line, which is a vertical line. So we know that x must be something, and that line will pass through the point 1 comma half. So it's x equals 1. Okay? Again, if you're not sure, if this is not clear to you, then what happens? Go to the graphing website, and then you actually draw the line and see what happens. Okay? So picturize, but again, when you do these kind of problems here, if you want to be strong in math, you should be able to understand the graph, and you should be able to understand the algebra independently. So you should be able to get the equation without any graphs. But if this algebraic method is weak and you don't understand it, the graph can help you. Is that clear? Or any other questions here? Any other questions? So now let's look at example, example 4. Example 4, y is equal to 1 plus x squared over square root of x. how do you find the derivative of this function right here? dy dx is the derivative of y with respect to x. The dy dx is so that's how we write it. So we write d dx. So this is how we write. We write what is it? dy dx. d dx of y. That's d dx of y. The d dx of y. This is we write this as dy over dx. So dy dx. You know what this dy over dx really means? The dy dx really means we start with the function y, and then we apply an operator. We call this an operator. dy dx. We apply this to the function y. That's what it is. So we have a y here, and then we take the derivative. That's what it really means. And then if you want to take the derivative one more time, then we put this d dx, the derivative of y. We have to put d dx of d dx of y. And so we actually, the y, not x. So this case, x here, x, and we put y. So we have a y, and then we apply this derivative, and then we apply this derivative again. So when you do that, that becomes what? That becomes d squared y over dx squared. This is the notation for the second derivative. If you use the functional notation, the second derivative is exactly the same as y double prime. Or in notation, the notation f, this will be written as f prime prime, f double prime. This this y dy dx. This one is basically y prime, and in the functional notation, this will be what? F prime. F prime, if we let y to be y equals f of x. If we let y equals f of x, then y prime will be the same as f prime. Okay? But this notation will be revised a little bit later when you get to the later section. You have to be careful, but for now, that's the notation. Now, let's come back to example 4. We now want to take the derivative of this guy right here. What rules do you think we should apply? What do you think is a nice rule to apply? What is the best way to take the derivative here?
Quotient?
Quotient rule? Let's see. Best way to take the derivative. The best way to find the derivative. Find the derivative of y. What is the best way to find the derivative of y for this problem? On this one, this is y right here. Y is 1 plus x squared over square of x. So now some of you may say, oh, that's quotient. So we have to apply the
You
quotient.
go, honey.
Yes, you can.
I made
remember,
just sweet, delicious
what
cheese
that
cocoa
rule of
just for
quotient
you.
is, you know what? Once you know the quotient rule, and by the way, the quotient rule is the ultimate rule of all the differential rules out there. You know, after this, we will be learning another rule called a chain rule. But even chain rule is not more complicated than the quotient rule. The quotient rule is considered to be ultimate rule. So if you know the quotient rule, you know what the first thing is? If you know the quotient rule, what's the first thing you have to learn? What you have to learn is, the first question is this: can we avoid the quotient rule? Can you do better? Can you do this better without applying the quotient rule? Of course, this 1 plus x squared over square root of x can be applied, can be written this way: 1 plus x squared, 1 plus x squared, and then instead of over square root of x, we can write this as x to the what power? Negative half power, and then apply product rule. But if you convert that to this form and then apply the product rule, that is not much simpler. So even though the product rule is a little bit more handsome than the quotient rule, you know, the quotient rule is still considered one of the ugly rules. So the question is, can we somehow find the derivative of this guy without quotient rule and even without product rule too? So yes, we can. You know, look at this. Can we multiply this? Yes, this is actually what? X to what power? Minus half power, and then plus x to the 3 over 2. Oh, is that a good thing to do? Yes, we can. So now, here's what it is. Let's look at the y here. Y is equal to, let's look at this, 1 plus x squared, and we have what? 1 plus x squared, and then we have x to the half power, right? So now, let's split this. So this can now be written as 1 over x to the power, which is x to the what power? X to the minus half power. And then plus x squared over x to the half power, which is x to what power? 3 over 2. Oh, you see this guy, don't you? Is this good or not? Is that a good thing or a bad thing? What is that? Now, once we convert the y into this, what rule can you apply now? We can now apply the power rule. So what is y prime? Therefore, what is y prime? Y prime? Y prime is equal to now, well, y prime is equal to minus a half times what? Minus half times x to the power, minus half minus 1, so that will be minus 3 over 2. Okay. And then plus, it's a sum. It's not a product, it's a sum. Therefore, now plus, and then what is the plus? What is the root of this one? That will be 3 over 2, and then times x to what power? Somebody tell me what it is. X to what power should I put here? 3 over 2 times x to what power should I put for the derivative? Anybody? This is now the derivative. And then now here it says, okay, now you have to find the second derivative as well. Apply the second derivative. Anyway, you can do this, alright? Just do it. There's no, okay, now let me just do this. This is equal to minus half times minus 3 over 2. And that will be 3 over 4. 3 over 4, and then times x to the power, x to the minus 5 over 2 power, minus 5 over 2. And then what is, and then plus, what is, and then now plus 3 over 2 times the half, that will be 3 over 4. And over, what? Over times what? 3 over 4 times x to the minus half power. Half minus 1 is negative half. So we get now this. So applying the, so once you get to a form like this, then you know what? We can just apply the product rule and apply that the sum and the difference formulas for the derivative. And then the final derivative, the second derivative is very simple. But if you apply product rule and quotient rule here, or quotient rule, it's going to be really messy. How about this? When you study example 4, maybe you should try to apply this. Maybe you should find the derivative by quotient rule and see how it compares. It is a good idea for you to apply quotient rule for study. But that is not the rule you want to apply when you see this on the test. On the test, you don't want to do that. Okay? So it is very important that you apply, that you find the derivative in the simplest way possible without making any mistakes. Is that clear? So I think you should spend a little bit of time coming up with a strategy. How should I take the derivative? It's very important. If you don't think and just apply the quotient rule, well, that will cost you mistakes, and that will cost you time. So applying quotient rule here will cost you extra time, and it will cost you mistakes. So that's a double whammy. Not a good idea. So that's why you have to think carefully here. If you know the quotient rule, what is the first thing you have to learn? If you learn the quotient rule, what is the first thing you have to learn? The first thing you have to learn is how to avoid the quotient rule. Again, in example 2, the one above this, that one, in example 3, we couldn't avoid the quotient rule. There's no way to avoid quotient rule in example 3. But example 4, there is. But sometimes you can avoid the quotient rule, sometimes you cannot. But if you can, you should avoid it, by all means. Any questions here? And by the way, the one before and then the one after this is now called the extended product rule. And there's a theorem here. Why don't you try to prove this? Try to prove this rule. Try to prove this rule. Try to prove the extended product rule. Extended product rule by assuming the regular product rule. The regular product rule. Yeah, right? So I think that will be a good exercise. This is in fact a very good exercise. Should take 1 minute. Should take 1 minute if you know what to do. If you know what to do. Of course, if you don't know what to do, then this will, you can't do this in 20 minutes, right? So you either can do this in 1 minute or you cannot do this in 20 minutes. But I want you to think about it, okay? So think about it. And if you can't do it, you know what? Then why don't you ask a tutor or somebody, or tutor for a course, or go to the math lab and ask them, okay? So and ask anybody in math, and they'll help you how to do it. But the key point is to understand in the structure of the theory. So this is the kind of problem I might give you on the test. Because if I give you a problem like this on the test, you cannot use any calculator, and it's difficult, but it's short, super short. So here the big question is how you approach these kind of problems. It is a logical problem. This kind of problem is logically difficult, but numerically very simple. Calculation, there's almost no calculation. So these are the kind of questions I like a lot. Difficult but short, very short, very, very short. 1 minute, you know what? It really takes about half a minute. Okay? If you really understand what's going on here. So the hardest part for these kind of problems is for you to understand what's going on. So I want you to try this and think about it. Don't just ask somebody for the answer. I want you to think about it, because remember, we math teachers, we have unlimited supply of problems. If I don't give you this one, I give you something else. So I have no limit of it. So if I give you something similar, and then I can't do that. So that's why you need to know how to learn this on your own. If you always copy from somebody and you always get the answer from somebody, you'll never be able to answer this kind of problem. Now remember, math teachers, we have unlimited supply of problems. If I cannot give you this one, then I give you something else. Okay? So I want you to learn this. Study, and think about it. That will be for the part of the learning. Okay? So save this, clear this. Now let's move on. Yeah, there we go. Example 5. Example 5 is actually the kind of problem which I gave you on midterm 0. This can be done. This problem can be done. This problem can be done without calculus. And in fact, I did give you this kind of problem before already. Try this. Do this. How about this? So do this problem. Yeah. So you do this. You do this. Okay. Now, since this is calculus now, and now we're in chapter 2. Now we learn calculus, and now we can do this by calculus. It's much easier this way. Okay. Now let's see. What is the question? Whenever you have a question like this, first thing is you have to what? You have to understand the question. Okay. Example 5. Find all tangent lines to the curve y equals x squared, which passes through -1, -3. And in this case, I have specified that the point -1, -3 is not on the curve. So let's first try to understand what the question is. What is the question here? So whenever you have a question like this, the biggest part is for you to understand the question first. Do not start the problem if you cannot understand the question. It's a no-no. If you do not understand the question and just start the problem, then you will just write a bunch of junk. Okay? And then there's the whole thing you write. The whole thing you write will be nonsense. So I don't want you to do that here. So make sure that you understand the problem first before you begin your solution. So let's try to understand what's going on here. So now let me just rough sketch here. And later on, when I get to the graph, I can explain to you. But right now, what we have is we have a graph y equals x squared. The y equals x squared, this expression everybody likes. Does everybody like y equals x squared? Yes or no? Do you like y equals x squared, class? Do you like y equals x squared?
Yes.
Yeah, y equals x squared, right? It's a lovely graph. I know, but it's like y equals x squared. It's like the shape of a tongue, right? Your tongue. You're sticking a tongue out, right? That's like a parabola, right? So this is a parabola. Okay, now this is a problem. Now the point -, -3. Where is that point? That point is over here somewhere. Somewhere here. Negative 1, comma, negative
Get your cocoa while still warm.
So now what are we trying to do now? Now, what is the question? The question is to find all the tangent lines to the curve y plus x squared. So what is that? Oh, we can visualize. Are we talking about a line something like this? Are we talking about a line something like this? Yeah, we are kind of thinking of a line like this. Is that red line? Is that the tangent line? Yeah, that's the tangent line. Roughly, of course. This is all an estimate. By graphing like this, we cannot really get the answer. Again, this graphing here, sketching method like this, we will not be able to get the answer exactly. And even if you use a graphing calculator, you cannot get the equation exactly. You can't. That was just an estimate. But obviously, this graphing or using a graphing calculator will help us understand the problem. Is that clear? Now, do you think that is the line which will be tangent to the curve and will pass through this point right here? Do you think this is the only tangent line to the curve which will pass through this point? No. Actually, there might be another line on this side. There might be another line on this side. Maybe a line over here somewhere. Line like this. But you know what? This is a question. Let me write this here. It's a question mark here. We don't know. Don't know. We don't know whether we will have a tangent on this side. So let me say, don't know. Don't know this. But you know what? The purpose of graphing or sketching a curve is what? Sketching is what? Is to understand the problem. The purpose of sketching is not to actually get the answer, but it is to understand the question. So now, does the graphing did that job? Yeah. Now we understand what the question is. So this is why you should try to sketch the graph or use a calculator. But again, no matter what you do, graphing or sketching a graph, you know what? You will not be able to get the answer, and you should not get the answer that way. Okay? Because that is still an estimate. Okay? No, but this cannot be, in this case again, graphing or sketching graph. Sketching graph. Sketching graphs, or graphic calculator. Or using a graphic
Torture
calculator.
chamber.
Graphic calculator.
My torture pod.
Calculator will you know what? Will help you understand the problem. But never prove the answer. By the way, even if your graphing calculator is super accurate and you get the equation exactly, I will not accept that. I will not accept that as an answer. That's it. Solutions. Let's see where the line. A solution line from the graph, graphing will not be accepted. The reason why I don't accept that is because that is
Where's
still
the
an
Russian?
even if your calculator is super accurate,
Come get your cocoa.
I will not accept that because it is still an estimate. It is still an estimate. All graphings are estimates. And so, again, solution line from graphing will not be accepted. Let me just, lay this straight. But it can obviously help you. So now the question is, how are we going to answer this question? Okay, so now solution. Let's get to the solution here. How do you get the solution? Solution? Let's get the solution here first. We have to get the slope. What's the slope? Now, purple or we have black here. Okay, now solution. How do you do this? Okay, so f of x equals what? F of x equals to x squared. Okay, x squared, all right. X squared. Now, find the tangent line. Now, here in this case, you want to find the tangent line? Yes. First, you want to find the tangent line. But note that we have the point right here. This is the point -1, -3. But this is not the tangent point. The tangent point is actually here. This is the tangent point. This right here is what we call the tangent point. tangent point. Tangent point? Tangent point. However, this tangent point is not given. It's not given. Oh no, we have to find it. But so we don't have the tangent given. But in order to find the tangent line, do we need to know the tangent point? Yes, we do. So, however, to find a tangent line, do we need to know the tangent point? What do you think? Do we need to know the tangent point? To find the tangent line, we have to know the tangent point. Tangent line. What do you think? To find the tangent line, do we need to know the tangent point? Yes or no? To find the tangent line, do we need to know the tangent point? Yes, we do. But here, we don't know the tangent point. So you know what we do? This is what we do. Find a tangent line to this curve. F at what? F A comma F of A, which is actually equal to, in this case, A comma A squared. Now in this case, since the tangent point is not given here, we make it fictitious. We make an artificial point here, and we call it A comma A. So this one here, since this is not given, we don't know where this is. So we are now going to call this guy A comma F of A. And this A will now be a parameter. That would be A comma A, which is equal to, in this case, A comma or A comma A squared. That would be A comma A squared. Now, note that we need a tangent point in order to get the tangent line. This negative 1 comma negative 3 is not a tangent point. Therefore, we cannot use this to get the tangent line. So we, in this case, we artificially mark a point here and call that A comma A. And now A comma A, the A will now be a parameter. It's an unknown constant. It is a constant. It's not a variable. It is a constant, but we don't know the constant. It is an unknown constant, which we call a parameter. This is an unknown constant. Unknown constant, which we call this unknown constant, which we call a parameter. This is called a, what mathematically, what do we call this? We call this a parameter. Parameter is not a variable. Variable is something which changes the value even throughout the problem. The parameter is a constant. We don't know what the constant is, but it is not changing value. If it's 5, it's 5. If it's 6, it's 6. So if you take the derivative of A, you get 0. It is not a variable. So in this case, what is that? Okay, so now from here, what we get is this. So what we get is this. So this is the point. So what we get is this. So we get from here, what is F prime? F prime of X is equal to F prime of X is equal to now X squared. F prime of X now equal to 2X. Now here, we try to find the tangent line to the curve at this point right here. So what is now the equation? The equation is now going to be this. Therefore, tangent line is equal to y minus a squared equals to 2a times x minus. So now this is the first step. Not done yet. First step done. Now what is this line here? This is a tangent line. We don't know what the A is. But this is a line whose slope is what? 2a. This is 2a. This is not 2x. What watch out. If you have mixed up here, then that will now be a critical mistake. This is not 2x. Some students, they put 2x here. Then they make a mistake. This is at the point a comma b at x equals a. So at this point, what is equal? It's 2a, not 2x. If you put 2x here, it's a critical mistake. That's a deadly mistake. If you put 2x instead of 2a, you will lose 50 points. That's it. The game is over, essentially. But 2a. And then it passes to the point a comma b squared. So we get this. So now, this is a line equation. This is a line equation. This is a line equation for the tangent line to the curve at the point a comma a squared. The first step is now done. And now, let's go to the second step. This is step 1. Now, second step is now 2. This is now step 1. So let me write this as step 1. Step 1. Now, let's get to step 2. What is step 2? Step 2? What is step 2? Must pass the point -1 comma -3. Step 2, now we have to use this step. So what is this? X equals -1 and y equals -3. Now substitute. Now we will be finding the edge. So what you do? From here on, what you do? You substitute. X equals -1, y equals -3. So we get -3. You know what? Maybe I'll just maybe that's better. So y is now what? Y is -3. -3. Then minus a squared is equal to 2a. 2 times a is -1. And then times what? Times x minus a. What is x? X is -1. -1, what? Minus.
Okay, so you said timer for 3 minutes.
Minus a is this, I guess. So this is what you get. Now, does everybody understand what I'm doing here? Does everybody understand what I'm doing here? If all of you understand what I'm doing here?
Yes.
Okay, and now all you have to do is what? Get the a. But substituting -1, -3. X equals -1 and y equals -3. A, we don't know. A is a concept, but we don't know that. So we're not substituting a value for a. Again, we don't know what the a is. We're trying to find the a. So we know that this tangent line is passing through this point. So we can plug this in into this point because we have a tangent line at a comma a squared. We want this tangent line to pass through the point -1 comma -3. So now if we do that, so now we get this. So what is this now? This is equal to now what is it? This is -3, the minus a squared. Let's multiply all that. What do we get? We get -2, so we get +2. We get 2 plus, and then we get plus. We get plus 2a. Get this. So now from here, what do we get? Let's see. Let's now get the next line. The next line is now this. Add a squared. A squared. You get a squared. A squared what? A squared. A squared. A squared plus 2a. A squared plus 2a. A squared plus 2a and the what? So what do you know? I get -1. What's this thing? A squared plus 2a plus 5. Did I make a mistake here? You know what? I did make a close mistake. What mistake did I make here? Can somebody tell me what mistake I made? I made a very bad mistake, but I found it. The mistake is, what is the mistake I made? The mistake
Is
is
3 supposed to be positive?
I replaced it a by -1, and that was the mistake. So this should reach a, not -1. So let me correct that mistake. When I correct that mistake, what is that? That will now be -2a. So this will all be wrong. All wrong. What is that now? That is now going to be what? That is now going to be -2a. say what? Minus 2a.
Hey Siri, stop.
This is what then now let me erase this. Erase this here. Now let me write this down. And what is this going to be now? So we bring everything to this side. Now bring everything to this side. What do you get? You get okay. So we'll I'm just going to highlight this. I'm going to write this down. So this is going to be 8 squared. Oh, what is this green square again? So what is this gray? I don't know why this gray shows up. Oh, you know what? I don't even know how to get this one. How did I get this gray thick? Thick gray. Black. This one. Still gray. I don't know what this is. Now what's that? So this is basically what? A squared. A squared. You know what? A squared. A squared. Plus 2a minus b equals to 0. So now we'll erase this example 6 here. As you can space. So now we are now getting close to the answer. So what is this? This is a plus 3. A plus 3 times what? Times a minus 1. Is that right? Equal to 0. Yes, that's right. So therefore, what we have is now what? Therefore, a is equal to negative 3, or a is equal to 1. Now, if a is equal to negative 3, what's the tangent point? Let's figure out what the tangent point is. What is the tangent point here? If a is equal to negative 3, what's the tangent point? The tangent point is a comma a squared. So that will be negative 3 comma 9. If a equals 1 is the point, if a equals 1, if a equals 1, what's the tangent point? The tangent point is what? The tangent point is 1. Now in this case, note that both of these lines have the point negative 1 comma negative 3. Because this point belongs to both. So let me write that down for you. Just to make things clear. What's the line equation? The line equation now will be y is equal to what? What is the line equation? The line equation will now be, by the way, I didn't write the slope. So let me write the slope. So what is the slope? The slope is equal to, what? It's equal to 2a. So what's 2a? 2a is equal to, 2 is minus 6. That's the slope. Then what is the slope on this side? Slope is equal to 2a, which is equal to 2 in this case. Okay, so now, what is the line? The tangent line is y plus 1, y minus 9 is equal to what? Is equal to minus 6, and then times what? Times what? X, 3 plus x plus 3. That's the line equation. What is the line equation here? The line equation here is y minus 1. Y minus 1 is equal to what? Is equal to 2 times x minus 1. So it looks like we got 2. At least from there, we got 2. So now I wrote down everything on both sides. For both of these lines. I wrote the value of A, I wrote the tangent point, I wrote the other point, I wrote the slope, and I wrote the equation. So this is the kind of thing which I'll be expecting. Okay? Alright?
So just a question, y minus a squared, it's not a squared, I mean a to the power of 2. Is that always going to be the equation, or is it only because f of x equals x squared, x to the power of 2?
Yeah. This y minus a squared is equal to 2a times x minus a. What is the line there? The tangent line. The tangent line is basically the tangent line to this curve at that point, at a comma a squared. It's this if you have a different problem with a different function or a different point, the tangent line will change. But what I am saying is, if you have any kind of a tangent line problem, and the tangent point is not given to us, then what? If the tangent point is not given to you, then you have to just, just name a tangent point. You have to fix, it's just the, equation. And in this case, call this guy a comma x ray. Because this point, -1, -3, is not a point. This guy's not a tangent point. So you cannot use it. But in order to find the tangent line, we need to know the tangent point, and the answer is yes. But in this case, we don't have it. So you just make up one. You just make up a tangent point, and you name it this way. In this case, that will be a comma a squared, because the curve is like this. So that's the first step. Now, this is not the only way to do this, to solve this problem, but this, I think, is one of the easiest ways. The most standard way. If you know any other way, and if it's mathematically correct, I will take that. This is the method I want you to learn. Is that fair? Again, this is the method I want you to learn. Okay? It's already 10 o'clock. Am I? I'm not, managing my time properly here. I'm a little bit concerned. Here. So you know what? What I'll do is, okay. So I guess we have to, before we take a break. How about this? Before we take a break, maybe I will. Okay, you know what? Let's just take a break. A 10-minute break. Okay? Let's just take a 10-minute break. And so how about this? 10 minutes.